Right then, welcome back. Let us look at this example together. Table 1 gives us a statistical output for a study on a robust optimization approach for the participated vehicle routing problem with demand uncertainty. The aim of the study was to reduce transportation costs while satisfying demands. In one study, the percent demand that is unmet, Y, and the percent of the vehicle capacity, X, are needed to meet the expected demand. There were records of 27 different scenarios. So basically, we are told that this table here and its result of the study, it's aimed to find more or less a better way to plan routes for vehicles making deliveries. And in this study, they wanted to reduce transportation costs while making sure that all packages were delivered similarly on time. They looked at 27 different scenarios and recorded percentage of demands it didn't meet. They used variable Y and the percent of the vehicles that were met or needed to meet the expected demand is represented using X. Now we are told that the tables here are provided gives us a relationship between the two variables between Y and X. Okay, let us try and look at table 1. If you look at table 1 here, it's a regression statistics table. It has multiple R, R squared, adjusted R, standard error, and observations. So you might ask yourself, what are these variables and basically what do they entail? So multiple R, that value tells us that there is a moderate relationship since it's at 40.73%. So this basically represents the correlation coefficient and it indicates the strength of the relationships between the independent and the dependent variable or Y and X. Simply just shows us how closely these variables are related. Similarly, the R squared value, it's 0.1659. If you multiply that by 100, we get 16.59%. This is also called a coefficient of determination. This tells us how much the variation in the dependent variable can be explained by the independent variable. In this case, since we have 16.59, this means this is how much was accounted for, and the remaining is what we couldn't account for. You'll see when we answer question number B. Now, adjusted R squared, it's basically our R squared adjusted, meaning in this case, it takes into account number of predicators in the model. So it's basically adjusted and gives us a more accurate value of how well the independent variable and the dependent variable are related. For the standard error, the value there, as you can see it, it's 0.3976. So if you multiply that by 100, it's like 40% or 39.73%. And this basically, it measures the average amount of the error or the variability in the observed data point. We are told that 27 different scenarios were analyzed. The ANOVA table that you see here, we basically went through it step by step on our previous example. On our next example, actually, we are going to have raw data and we will be using Excel to extract this entire table in its entirety. So this table that you guys are looking at here, it is basically information that is provided to us about the coefficients or the slope of the regression model from the data that was collected. So the first row here, as you can see, it represents our intercept. And the value there is minus 2.69. This is basically the representation or the estimated value of the dependent variable when the independent variable, in this case the vehicle capacity, is 0. So it just shows us the value of the dependent variable when there is no vehicle capacity. So this error of 1.6153 for our intercept coefficient, it basically measures the average amount of the error in the estimation of the coefficient that was determined over here. The t-stat was found to be minus 1.66 for our intercept coefficient or the first row, and it basically evaluates the significance of the coefficient by comparing it to its standard error. Since it is minus 1.66, we can say that it suggests that there may not be a significant relationship between the intercept coefficient and the dependent variable. Our upper value and lower value at 95% confidence interval for the first row or the intercept coefficient. So this is basically the range at which we expect to find the true value of the coefficient. So here are the answers. On our previous example, we looked at how one can actually go through the manual equation to obtain the value. Now for our second value, the 0.0391 value that you see here in this scenario represents the vehicle capacity coefficient, and basically stating us that for each unit increased in vehicle capacity, the dependent variable, in this case is the percent of the unmet demand, is estimated to increase by a 0.0391. For the second row, our T statistic value is positive 2.297 for the vehicle capacity coefficient. And in this scenario, it determines the significance of the coefficient. Hence, we can say a higher absolute T statistic suggests a strong evidence of relationship between the coefficient and the dependent variable. Okay, let us solve the problems. So for our first problem, the question there is, write the equation of the fitted model. Based on the scenario that we had previously, we are going to take the intercept value. It was found at minus 2.6903, and the vehicle capacity value, which was found at 0.0391x. Hence, we can write our equation in this format here. You might have seen this from mathematics, your linear equation. Using the coefficient of determination, assess the model fitness. We did say that our R value, the squared value, was found to be 16.59. You can run it off to 17%. So this means, like we said there, we only accounted for 17%, and the remaining 83% is unaccounted for. So the model definitely is poor. The higher the R squared value or the coefficient determination, the more effective or fit the model is. And lastly, using the F statistic, assess the model fitness. So from our table, we saw that the F value for the regression model was found to be 4.9716. And to assess this model significance, we have to compare the F value to the critical value at a given significance level, assuming A or alpha to be 0.05. On our table, we saw that our p-value is actually 0.035. The significance level is 0.05. Since our p-value is slightly less than our alpha value, we can say this model is partially fit. I really hope that makes sense. Thank you so much for watching.